Hi students, welcome back. Video lesson 2, video E. We're still looking at graphs of quantitative variables, so just a few more notes on histograms, and then we can move on to actually calculating summary statistics rather than just eyeballing them from the graphs. All right, estimating the center spread and unusual features from histograms. We've got to pick a number, one number that describes the center. If we're using a histogram, we're going to want to eyeball it. We've done it in the previous video where we're going to try to split the area into two equal pieces. Area, left and right of the center. So we'll eyeball a single value. We'll do better. We'll start calculating statistics in lesson 4. But for now, pick the value that splits the area 50-50. This is an estimate of the median. Spell it right and say it right. Median, M-E-D-I-A-N, is the median. It's the middle value. If I organize my data values smallest up to largest, it'd be a value that goes right in the center that chops it into two equal pieces. So we've done this before. This is a quick review, so we are going to go rather speedy. Estimate the median for each of the following histograms. Number of children from the general social survey. I'm trying to split the blue bars into equal pieces. All right? Couple of points. If I went right here at the split between the rectangles, that's not far enough right. If you stack this rectangle and put this one on top as half of the blue, and did the same here, I've got much more to the right of that line. Likewise, if I put it there, there's much more blue to the left than there is to the right. So the median has to be somewhere in between those two. Lucky for us, this data set's very easy because it's just a bunch of zeros, ones, twos, threes, fours, and fives. So somewhere here is the median. The value's 2 as we discussed in the previous video. And again, this would be half of the area, right? These are half of the people, and 2 is the number that chops it up. Okay? So that's going to be for sure the exact value of the median. I guess we're going to look at hurricanes here. Same page over to the other side. And again, estimate the median. All right, so let's see what I did in my notes here. Yep, somewhere in here. If I chop right here at this nice breaking point, which looks to be 990, there's a little bit more area to the left of 990 because if I took, here's 2 exact same height rectangles. If I took all these and stacked them up, there'd be more over there. So I have to really estimate this one here. It's somewhere just to the left of that 990 line will be the median. I don't know precisely what that value is. I couldn't even regenerate it from the data set. Okay, but I'll tell you what I wrote in my notes. I took the easy way out. I said the median's between 980 and 990. All right, so median is somewhere in between 980 and 990. Okay, so if you tell me split the difference and just call it a 985, you're safe. Okay. You have to be very careful. There's hugely incorrect answers. If you say 980 is the median, look how much data is to the right of 980 compared to the area to the left. Right? This is not an acceptable answer. It's too far off. So it's somewhere in here. If you said 985, whatever, all perfectly good answers. All right, so that's how we'll do the spread if we're just looking at a histogram. Or excuse me, that's how we'll do the center. Only looking at a histogram. So 4 things, remember, right, students? Shape, center, spread, unusual features. 2 are done, 2 to go, spread. We need to report a range of values that covers most, if not all, of the data. Dealing with outliers might be a bit tricky. Okay? So example, discuss the spread for the two variables pictured, I guess, above in the notes. Let's see what we've got here. I go backwards. Talk about the spread. This is the number of children again. Very easy. Values range from 0 children up to 8 children. Right? I should probably write it down, and so should you. Values range from 0 to 8 children. With this histogram, that's probably as good as we can do at this point. Now, we've mentioned measures of spread. That introductory McDonald's example, we're going to work towards calculating a standard deviation, which is the average distance to the center, right? How much spread is there? It's the average distance to the mean. But for now, looking at a picture, that's the best we can do. Values range from 0 up to 8. How about on hurricanes? We do have to be careful. I don't know, students, do you want to call this an outlier because there's space? It's a judgment call. Certainly these are not outliers. There's quite a bit of data in here, and this is probably, for all intents and purposes, not an outlier. But I don't know that the lowest pressured hurricane was exactly 920 millibars. There was one data value somewhere in between 920 up to 930. Likewise, on the high end, would be what? 1010 would be up here. I have 4 data values that were somewhere between 1000 and 1010. I don't know their exact values. It's lost when you create a histogram. So we just want to be careful, cover our bases. For hurricanes, values range from, it's one word, but put it in there. About, you put a little squiggly in front of it too, 920 millibars. I don't know the abbreviation of that, or I would have put MB, but I'm not sure what that is. To about 1010. Here, I'll invent an abbreviation. I'm not sure if it's right. So be careful. We don't want to say things that aren't true, so don't say that they range from 920 to 1010. It could be actually sort of far away from that in reality. All right. Flip the page, flip the slide. Let me erase this so I can see what this even says. Spread. We need to report a range of values. Oh, I know what happened. I went backwards to get to the pictures. Here we go. Unusual features, students. If the variable has an unusual shape, note it down. I'm not sure what an unusual shape is, but you know, if you collect your data in a histogram, and the histogram looks like this with data piled up on the low values and data piled up in the high values, and it's sort of an unusual shape, I might comment on that. Aside from an unusual shape, look for those unusually low or unusually high values and note them down specifically. If you can figure out what the values are, tell us. It's a big pet peeve of the stat instructors where a student will just say there are outliers. Give some details. Are they high or low? Can you approximate or give their actual values? Okay? Let's not be lazy and just say there are outliers. Let's not be lazy and say there are unusual features. Let's be careful and give the details. Typically, these are some of the most interesting data values we have, so let's learn about them. To wrap up this lesson, you'll be asked to describe a quantitative variable. You have to write in complete sentences, you have to make it sound good, and you have to hit the main points. What are the main points? You've got to mention all the features about shape. You've got to estimate the center. You've got to describe the spread. And you've got to give details about any unusual features or outliers. couple of important points here in red. Not sure if the red's coming on the video or not, but number one in red, if there are no unusual features, please say so, students. That way we know you're thinking about it. If you omit, we won't know if you even remembered, so if there are no unusual features, say so. And finally, write in complete sentences, because this is college. Final example. Then we're going to call it a day. There's some lines to write. I'm going to write mine on the board here. Looks like we're back to the general social survey, but we've got a new variable. People were asked, how many hours per day do you watch TV? Clearly, we're videotaping this in the year 2013. You may be watching it in the year 2020 for all we know. But times are changing now. I'm not sure who watches TV on a TV. If you're watching on your computer, on Netflix, on a tablet, etc. Okay, but this was from 2008, so just to keep that in mind. Describe the distribution of the variable. Let me say what I'm thinking, and then we'll write in sentences. For sure, this is unimodal and skewed to the right, so we're going to talk about that. When I talk about the center, I want to split the area 50-50, all the blue stuff. How can I do that? Somewhere in here, somewhere in there is the 50-50 marker. Could be a little bit to the left or right of my squiggly line. And what value does that look like it is? These are in terms of 1, so this would be 2 and 3. If you said 2, if you said 3, if you said, I would probably accept all of those as good estimates. Most values range from about 0 hours up to here, which is about 12. And it certainly seems like I've got some outliers. Here's somebody that watches, actually more than a person. They watch 24 hours of TV every day. Every day. I guess the TV's on. So even in these official big data sets, there's always errors and typos and strange things. Let's write it out. Let's call it a weekend and get out of here. All right, describe the distribution. TV hours are unimodal and skewed right. With, usually I can do this in 2 sentences. So I'll say with most values ranging from about 0 to 12. With most values ranging from 0 to 12 hours. We've covered shape and we've covered spread. We still have center and unusual features. How about I cut it in half? How about I say 2.5 hours? 2.5 TV hours seems to describe the center of the distribution. And last but not least, those outliers. I guess anybody from about, 14 up to 25, I would call those outliers. My eyeball test says those are high outliers. So, and anyone watching 14 to 24 hours per day is unusually high. No pun intended there. TV hours are unimodal and skewed right, with most values ranging from 0 up to 12 hours. 2.5 TV hours seems to describe the center of the distribution, and anybody watching between 14 and 24 hours is unusually high. It's an unusually high TV time. Okay, so that ends this video. Thanks for watching. We'll see you in class, and take care.